Assalamualaikum, selamat sejahtera. We continue about 7.2 acid-base titration. Now I want to show you the acid-base titration in quantitative. That means we want to calculate the pH of the analyte after titration, before titration, and sketch the titration curve based on the pH that we have. Okay, for this exercise 1, in the titration process, total 30 ml 0.2 molar sodium hydroxide is added dropwise into conical flask containing 25 ml 0.2 molar HCl. Calculate the pH of the solution before addition, at half equivalent point, at equivalent point, and after addition 30 ml. Lastly, sketch the titration curve. First of all, when you get this question, you have to sketch the titration apparatus roughly because you want to determine what's the titration involved and what the analyte involved. For this case, based on the statement, sodium hydroxide is added dropwise. That means your titrant is NaOH. Into conical flask containing HCl. That means your analyte is HCl. After you determine what is the titrant and analyte, you classify this is strong base, this is strong acid. That means this titration involves type 1, which is strong acid and strong base titration. Okay, tak kisah titrant itu strong acid ataupun strong base, tak kisah analyte itu strong acid ataupun strong base. As long as they adalah strong and strong, we refer to the type number 1. Okay. Volume for the titrant is given about 30 ml. That means total 30 ml here. That means the last volume NaOH added to the analyte is 30 ml. The last volume, which is 30 ml. That means before 30 ml, it involves another value. The molarity for NaOH is 0.2 molar. HCl containing, consists 25 ml. That means the volume of analyte, and the molarity is 0.2 molar. Now, focus question number 1. Before addition NaOH met, that means before titrant added to analyte, you have to calculate pH of the solution. pH of the solution here, all the time I refer to the pH analyte. That I told you before, always we refer to the pH of analyte. For this case, before you added sodium hydroxide, what's the pH in this conical flask? This I refer to the question number A. So, when we refer to the conical flask, it only have HCl. HCl is strong acid. Okay, refer to the solution in conical flask before added NaOH. So, if you have only the solution which is strong, that means you must use if table. Still remember? Okay. If you want to use if table, you have to starting with the dissociation equation. So HCl, single arrow. Why we use single arrow? Because it is strong acid. Strong, that means 100% or completely dissociate. We become its ion. Okay, so this is initial, this is final, always molarity. The molarity of HCl is 0.2. So this is 0.2, 0 and 0. At the final, concentration for HCl is 0 because completely dissociate. This will become 0.2 and also 0.2 because the stoichio is 1 to 1 for cation and 1 to 1 for anion. So for this case, from the if table, concentration H plus is 0.2. Thus, pH can be right negative log concentration H plus negative log 0.2, and you get the answer is 0.70. This is pH before added NaOH. Now we go to the 1B. Calculate the pH of the solution at half of the equivalent point. So, when you said half of the equivalent point, you have to understood what means by equivalent point. Equivalent point is the mole acid and mole base are completely reacted. Okay? So, first of all, okay, you have to find for me the volume at half equivalent point. Okay, volume what? Volume titrant. So I want to know what the volume of titrant is added to the analyte when the reaction in this conical flask reach half equivalent point. So what I want to do is at equivalent point, okay, mole acid with symbol with H plus is equal with mole base with symbol is 0 OH minus. So that means you have to use MAVA or MVBB. Okay, 1V1 over LB, 1 over 1. Okay, here the stoichio here I put 1 over 1 because when HCl react with NaOH produce NaCl and H2O. The stoichio here and the stoichio for acid and base is 1 to 1. So I can write like this. Simplify like this because the stoichio for acid and base is 1 to 1. Alright. So you just substitute the molarity acid and molarity base for from the theta. So molarity acid is 0.2, volume acid 25. This is volume in conical flask. Molarity base we want to find, molarity base is 0.2, volume base you want to find. So you will get 25 mil here. This is volume at equivalent point. Okay, volume at equivalent point. But the question asks you half equivalent point. That means the volume must be half. So at half equivalent point, volume base is 25, or divide by 2 become 12.50 mil. Right? So that means when you added 12.5 mil NaOH di dalam conical flask, you telah mencapai half equivalent point. Okay, after you get the volume base, that means volume titrant, what you should do? You find the mole HCl by using mv over 1000. Molarity 0.2, 25 over 1000, and we get 5 exponent negative 3. And mole NaOH using mv over 1000 to 0.2. Volume NaOH refer to the volume titrant here at half equivalent point. You get 2.5 exponent negative 3. This is mole in conical flask. This is mole in from burette at half equivalent point. Okay. Next, you have to use ICF table. Automatically, first part you cari dulu volume titrant. Okay, the second part you cari mole. Okay, mole for acid and base. And the third one, terus you cari ICF table. Okay, macam mana nak buat ICF table? As usual, kita kena buat equation dia. NaOH react with HCl because you involve type 1, iaitu strong base and strong acid. As usual, produce the salt here and water here. All the substance is aqueous phase. Okay, your H2O is liquid. Okay, why I use AQ for this salt? Because the salt is completely dissociated. Okay, now I for initial, C for change, F for final. When you use ICF table, the unit is only one, which is mole, that you learned before. Okay, mole NaOH here from the part 2 here, which is 2.5 exponent negative 3. HCl is 5 exponent negative 3, and ACl is 0, not produced yet. H2O liquid, since the phase liquid, not involved in your ICF table. Now, for ICF table, as usual, we don't use the X, unknown X. Okay, only I table we use X. For this ICF table, as usual, you must select the value that has limiting reactant. That means compare the first reactant here and the second reactant here. Which one has the smallest mole for the initial? The answer is NaOH, because the smallest mole in the initial row. So you put the smallest number of mole here for all species. As usual, reactant will decrease the concentration. Reactant decrease concentration, you put negative, and your product is positive, increase the concentration. The final mole, that means I minus C. That means will become 0. 5 minus 2.5, 2.5 exponent negative 3, and we have 2.5 exponent negative 3. Okay. Now, di bawah row final, gariskan satu garisan panjang untuk you tambah molarity row. Okay. Molarity. Molarity unit M besar. Formula dia N over V total. So here we become 0 sebab final mole dah tak ada. Yang ini 2.5 exponent negative 3 divide by volume total here refer to the volume HCl plus volume NaOH at half equivalent point. Volume HCl adalah volume yang berada pada conical flask, iaitu 25. Volume at half equivalent adalah yang ini 12.5. You tukar menjadi liter. You dapat molarity di sini. Okay, yang ini 2.5 eksponen negatif 3 bahagi 25 tambah 12.5 tukar menjadi liter. Get the molarity here. Molarity for HCl is 0.0667. How about NaCl? 0.0667. Okay. After you get this, okay, you comparekan molarity yang tinggal, bermaksud yang berbaki di dalam conical flask ada 2 molarity, iaitu molarity daripada HCl dan molarity daripada NaCl. Ini yang berada di dalam conical flask. Both yang ini berada pada conical flask. Dan kita memang nak cari pH di dalam conical flask sekarang. Okay, selepas kita addedkan titrant sebanyak 12.5. Okay, now kita nak merujuk kepada molarity yang mana satu? HCl atau NaCl? Kita tengok. HCl adalah strong acid dan ini adalah the salt. So, kalau you nampak ada campuran di dalam conical flask itu antara strong acid dan salt, kita ambil siapa yang lebih dominan. The answer is strong acid. Mereka berada di dalam conical flask yang sama. Strong acid dan the salt, campuran itu berada dalam conical flask yang sama. Tetapi kita kena ambil yang mana lebih dominan. So dominan di sini tengok siapa yang kuat, iaitu strong acid yang lebih kuat all the time. Okay, so that means kita akan manipulate this data. So kalau dia lebih dominan di dalam conical flask, bermaksud seolah-olah di dalam conical flask itu hanya ada HCl. So agak-agak macam mana kita nak cari pH HCl? Yes, since yang berbaki itu adalah strong, that means you kena guna if table to get the pH. As usual, you starting dengan equation. Single arrow, 100% dissociate, become H plus and Cl minus. Then initial is 0.0667. Okay, this is the molarity for your HCl. 0 and 0. Final is M besar. 0 because 100% dissociate becomes 0.0667, 0.0667. So concentration H plus equals to 0.0667. Thus pH equals to negative log 0.0667. And you get the answer here 1.18. This is a pH after you added half at equivalent point.